So in this lesson today, we're going to talk about how to solve quadratics with graphing. So first of all, we need to recall that solutions are also called roots or zeros or x-intercepts. So in the directions of the question, if it asks you for one of those other things besides solutions, i.e. roots, zeros, or x-intercepts, then we're talking about what we are going to see today in the graphs. So we can look at graphs to determine how many and what types of solutions there are. And sometimes we can actually see even what the solutions are, and that's what we're going to talk about now. So with the first one, it says determine how many and what solutions are. So in example 1, we have this equation y equals x squared plus 12x plus 36, and then we put that into some sort of program, either your Desmos or in your calculator, and you get this graph. Well, when we look at this graph, it says, by looking at this graph, you can see that it touches the x-axis at x equals -6, right? So that is our one and only place where it touches the intercept. So it says this equation has only one solution, and it's a real solution, and it's a rational solution. It's real because I can see where it intersects the x-axis, and it's rational because it's a whole number. So the next graph is example 2, and it says, again, determine how many and what types of solutions. So this one's y is equal to x squared minus 3x minus 10. Again, we'd put this in a calculator. And we do that, this time we can see that it intercepts the x-axis. This graph intercepts the x-axis at -2 and at 5. So those are where -2 and 5, right? And then it says this equation has two solutions, and they're two real rational solutions, right? They're rational, again, because they are whole numbers, okay? Integers. So the next one is example 3, and this one is y is equal to x squared plus 4. Now, the difference with this graph when we put it in is it didn't intersect the x-axis anywhere. So since this graph has no intersect, or does not intersect, gosh, that's a not, does not intersect the x-axis, there are imaginary solutions, okay? So when it doesn't intersect the x-axis, we have what's called imaginary solutions. This means there are two imaginary or complex. We're going to call this also complex. So remember, complex and imaginary mean the same thing because a complex number has an I in it, right? So this means there are two complex solutions or imaginary solutions. Then it says, can you tell the value of the solutions by looking at the graph? And the answer to that is no. Now, we could solve the equation and figure out what they are because we have the equation. And if you notice, what we could do here is put 0 here. Then we would move the 4, so it would be -4 is equal to x squared. Take the square root of both sides, and you should be able to see that the values here are going to be x is equal to plus or minus 2i, because we can factor this to be the square root of -1 and the square root of 4. So those are our imaginary solutions. We can solve it for this one because we have the equation. So on the next 3, what I'd like you guys to do, these are the U-tries. Go ahead and do them, and then come back to me when you're done, and we'll check your answers. So on the first U-try, again, where do we see the graph intersecting the x-axis? I see it at x equals -2 and x equals 2. How many solutions? There are 2 of them. And what kind are they? They are real. And these are rational because, again, they're whole numbers, right? So this next one, does it have any x-intercepts? Nope, there are none, right? Then how many solutions does it have? It has 2. What types of solutions? This time it's imaginary because it does not intersect the x-axis. On the third one, again, we're looking at the graph. I can see that's between 0 and -2, so this one's going to be x equals -1 and x equals 3. How many solutions? Again, 2. What kind of solutions? These are real, and again, these are rational solutions. Now, when would it be irrational? Is when we would have something that would not be hitting where there's a whole number, okay? And down at the bottom it says if the solutions of the graph are imaginary or not nice values, you can use the other methods we have learned to solve for the values. So on this one it says give examples of when you would use each of the methods of solving. So when do we use square roots? We use square roots when we have no x to the first in the problem. So in other words, we're going to have something like ax squared plus c equals 0. We would move that c to the other side and we would just divide by the a and then take the square root, okay? When we're talking about factoring, we're looking for patterns here. So that's what I'm going to write, looking for patterns. Okay, so in this one, we're looking for example, a pattern like a squared minus b squared, right? So two perfect squares subtracted from each other, or a squared plus b squared. That's the one that has imaginary solutions. Or a to the third minus b to the third. Those are the difference of two perfect cubes, or the sum of two perfect cubes, right? These are the types of patterns we're looking for when we're factoring. Now, obviously, you can use factoring other times as well, and you will on the test. Completing the square. When I'm looking for using completing the square, I'm looking for something that has no leading coefficient. That means there's no a, or a is equal to 1. So this is when a is equal to 1 in ax squared plus bx plus c, okay? Let's see. The b is going to be an even number, okay? So when I'm talking about this, y'all. Ax squared plus bx plus c equals 0. So here, no leading coefficient, so a is going to be equal to 1, and b is going to be an even number, okay? And then when do we use the quadratic formula? We can use the quadratic formula actually anytime, but I wouldn't use it for most things because it's a lot of work. So here's the thing. Your x here is going to be equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And also the other challenge with this is there's a lot of room for error, okay? So sometimes it's easier to use other methods. That's why we've taught you other methods. And then when we use graphing, we would use graphing when we can see where the graph. So basically, when you can see where the graph crosses the x-axis. And that would mean you'd have to put it into some sort of program that's going to show you the graph, right? All right, so let's look at these equations next and see which ones we would use and why. So it says we're going to decide which one we're going to use. So first thing I'm going to do is put these in standard form. So I'm going to do x squared minus 6x plus 17 equals 0. When I look at this, I have a leading coefficient of 1 and I have an even number in the b position. So I would use completing the square for this one, okay? Now I'm not going to do them here just for the sake of time, but that's the method I would use, okay? And then for the second one, I can look pretty quickly. Again, I would put 0 here, and then I can see that this is going to be negative 24x squared. I think that one's going to be an easy one to solve, y'all, so I would do factoring here, because the factors of negative 24 that add up to be negative 10 are negative 12 and 2. So I would use factoring here. This next one, notice I don't have a b, right? There's no b. So because there's no b, then I'm going to use square root. Okay. For number 4, again, I'm going to put it in standard form, 2x squared minus 3x minus 10 equals 0. I'm going to look at this, negative 20x squared. Don't think there's any factors of negative 20 that add up to be negative 3. So this is one when I would use the quadratic formula. Also, I have a b, and b is not even. So that's why I would use the quadratic formula for this one. This last one, honestly, I could use a couple different methods. I could use factoring, right? I could use, well, my middle term, I wouldn't use a square root because I have a b, and I wouldn't use completing the square because b is an odd number, it's a 1. So I would either use factoring here or the quadratic formula, or graphing. And honestly, on this one, graphing might be the easiest, okay? So you could use any one of those methods. Now listen, on the test, it's going to tell you which method to use. So use the method that you are being told to use on the test.